All right. Hey, everybody. Thanks for joining today's nTop Live about conformal bone plates and automatic feature generation. Today, I'd like to show a medical device workflow in nTop platform on the patient-specific side of things. This skull right here belongs to an individual that we've endearingly named Chad. And due to an unfortunate rock climbing accident, Chad suffered a bit of head trauma and a fractured skull. And as a result, needed to have a cranial maxillofacial bone plate to serve as a sort of scaffolding during this healing process. Now, this design workflow is actually able to look at the center location of the fracture and actually generate a CMF plate that conforms to what Chad's skull shape should have been at that location. Now, there are a few exposed inputs here, such as the size of the mounting holes, their positions, thickness of the plate, and other such features. But the best part of the workflow is actually down here, where we estimated the position of the offending rock that caused this trauma to begin with. Now, normally each patient-specific solution requires a lot of manual data processing, some very specific implant modeling, and a lot of labor to ensure conformity. And we've been told by quite a few companies and design firms that, a custom implant can take a very long time to design, and it can be an operational bottleneck when trying to determine what the right approach is to provide the best patient outcome in each situation. So with a robustly designed workflow, we can actually do something interesting here, and we can actually move the position of this rock to, let's say, the other side of his head. Now, I'm going to bump that resolution to make things render just a little bit faster. Um, but essentially, the rock will move, the simulated hole in the skull will regenerate, and the bone plate workflow will actually pretty intelligently a conformal scaffold at this new location. Um, Now, looking at this specific injury, it would make sense if the skull structure doesn't happen to be available for head injury like what Chad has, right? Usually, a patient like this with this kind of accident will, come into the hospital with this section of his skull missing, right? And that's what we're trying to fix here. But it is very easy to tweak this workflow to reference the opposite side of the skull and just mirror the results to the correct side. So if I scroll down and toggle the visibility of this new plate, we could see it rendering up right now. And what we're going to see is that bone plate conforming to this new location. Let's give that an extra few seconds. And there we go. Right. So this is going to be the result of the exact same workflow, just applied to a different location. So we saw this update only in about a matter of a minute. So even if there was a bit more added complexity or design steps that still needed to be taken that may have been specific to a, Chad specific case here, we're already really 95% there in terms of getting a final geometry, right? The hardest part here is getting something conformal, and we've achieved that with little to no effort. Now, the amount of time that can be saved as a whole for this design process can be on many orders of magnitude. This means that the users of nTop platform who design patient-specific solutions, they can reduce their cycle times, and that really enables an increase in volume and throughput for their business. A similar example here, oops, a little bit of cheating there. But a similar example here is Chad's upper arm. And Chad here has shown himself to be a bit of a risk-prone individual, let's say. So he's got a few fractures in this humerus. And let's just say that's due to a mountain biking accident. Off the bat, we can see a bone plate has already been generated to address one of these fractures. However, you'll also notice that a set of points in blue floating just above them. And these points were actually the origination criteria for this bone plate. So given a few of these input parameters and the positions of these points, the workflow in nTop platform here generates this bone plate for you. Now over here on the left, we can see all these input parameters called out and this big expandable workflow right here that defines output geometry. If we open this up, we can see that this whole workflow has a lot going on and it can be tweaked and toyed with, right? But if we have a revision controlled process, that we know works and shouldn't be modified beyond what we see right over here, I can actually bring in a compounded or a compressed version of this exact same workflow and use that instead. So I'll come in, import this bone plate generator file, and I'm going to search for that in the search bar. And you'll see that this block that I've made over here is actually a compressed version of the exact same bone plate workflow. Right? You can see the plate thickness, the corresponding bore depth, offset values, smoothing values. That's all there, right? But now it's closed off with the ability to kind of remove any human error from accidentally messing with some values that a designer of this workflow didn't want you to mess with. It also protects intellectual property because it hides how the workflow itself is actually put together, concealing some of that information. And this bone plate is going to be generated from this workflow in a kind of an automated fashion. So it kind of reduces these other operational risks of accidentally, again, tweaking numbers that shouldn't be tweaked. So filling in the blanks, I can bring in the humerus as a reference bone geometry. So start typing in humerus, and we can kind of access the same smart search functionality by typing within the input field itself. Grab onto that humerus as an input, and we're actually going to import a set of points. Choose a millimeter unit scale, and I'm going to import, let's say, bone plate 2. So these points are now in position right over here. And in just a few, we're going to see that a bone plate will be automatically generated around the position of these points. I'm going to change the color of these points to a quick blue, kind of separate their visual clarity. And there you go. I can do this once more by creating another bone plate. So let's call this blue. Create another block, and we'll call that bone plate 3. And we'll do the same thing. We're going to choose the reference bone geometry, which is going to be humerus. We're going to import another set of points that has been previously designated. Unit scale. And we're going to grab the points for bone plate 3. And you'll see that we're choosing a CSV data import points. So it's just as easy as putting them in that format. So you'll see those points designated from that import, and the workflow is going to generate that bone plate around it. And that's how we're sending this theoretical fracture. But once it generates, we notice that there may not be enough material here to safely span the gap of this specific to withstand the loading conditions that this portion of an arm may typically experience, right? So thankfully, the forethought here was considered to potentially material to a bone as a bit of caution, and that has been included in this workflow. So down here, I've got this option called the material offset value set to 1.5 millimeters. And if I bump this up to 1.75, it's going to regenerate the entire bone plate. But what we'll see once that finishes is that the material around each hole has been beefed up by just a bit. And now we can see that the material that spans the distance of the gap here is now a little bit larger, and it's within reason to consider this to be okay. From this step on, you do static analysis, kind of verify and validate that this design concept works and makes sense. But the only way to approach this bone plate generation is now kind of ready to go. So this is a pretty simple way to address the need for more material if you were to tweak this number here. But there really are a lot of other approaches and solutions that are possible as long as they are considered with forethought and built into the workflow itself, right? This option that I changed here, what it does is that it bumps up the amount of material built or generated around each hole. But if you didn't want to do that, you wanted to just add more material over this span gap, that's something that you could build into the workflow as well, right? Build in that flexibility. But at the end of the day, all these approaches can still originate from only a base set of points. So I've been referring to points a lot, but when I say points, I don't just mean like these points that you see in coordinate space. What I also mean is that a surgeon can actually look at the shoulder of a design engineer point to the locations where his experience tells him these bone screws should go. And the design engineer can use a workflow like this to generate a bone plate solution that matches both the patient's needs and the surgeon's needs based on his experience. So using the nTop platform, not only are you empowering the design engineers by providing these robust tools and essentially giving them their time back, but you're also closing the gap between surgeon and solution to just ensure better patient outcomes overall. So, if anybody has any questions, please don't hesitate to throw them at me now. Um, I hope that this was interesting and perhaps it'll inspire some design ideas that you might have. But what I've shown here today is not intended to be, a be-all and end-all solution to create bone plates. This has just been a showcase of what nTop platform can offer as a design platform. Create solutions that work for your specific business needs and your specific requirements. So yeah, if you have any questions, feel free to bump over those now. Just give an extra few minutes to let those questions roll in. All right, bit of a quiet audience today, so we don't have any questions. So I am going to close it out. But as always, if you do have any follow-ups or any further thoughts, would like to get any more information about nTop platform as a whole, feel free to go to our website or reach out to us at sales@ntopology.com. Thank you.